Right, so this is Thursday's lesson. It's just finished, and instead of hitting record during the lesson, I thought, let me rather record it again so it'll be a bit more succinct, although we'll ask the same questions. So what we wanted to look at today was there was a good question about these examples that say y equals or x equals. So we're looking at horizontal and vertical lines. That's what we're looking at for this one, and we don't need that. Okay, so let's run through a few examples. Our first example we started with was to say, what is the graph of y equals 4? What does it look like? How do we sketch it? What's its gradient? What's its y-intercept? Let's start by sketching it. And from there, we can look at a few things. Now, if we're given an input of 0, so we want to see what the y-intercept is. What is the output? So our input is 0. What's our output? Well, we're asking, how do we find this out? And the ideas came back to say, well, we substitute. But now it looks a little bit weird because there's no x value here. So how are you going to substitute x equals 0 when there isn't an x? So let's look at this and say, what's the standard form for any straight line function? So that standard form you should be able to rattle off in your sleep to go y equals mx plus c. And from our standard form, we can tell a few things. We can tell, what does the m tell us? Well, the m tells us what the gradient is. So our gradient is given by m. Okay, what does the c tell us in our function? Well, the c gives us an indication of what the y-intercept is. Okay, so let's rewrite this equation. Let's try and write it in the standard form. Y equals something times x plus something. Well, the plus something is given to us, right? Because that's plus 4. But there's no x in this equation. So what can we multiply x by so that it kind of disappears? Well, Tristan came up with a nice idea and said, well, why don't we just multiply it by 0? Because 0 times anything is 0. So then, goodbye x. Completely agree. Y equals 0x plus 4. Hey, 0 times x is 0. So y equals 4. So these two equations are the same. So now we can look at it and say, the number in front of the x tells us our gradient. What is our gradient of this function? Well, it's 0. It's told us to us. What about the y-intercept? What is the y-intercept of this function? Well, 4, or more correctly, 0, 4. Well, there it is in our graph, 4. So let's scroll down and substitute some points in. We know that point. But what's our graph going to look like? Is it going to look like, well, is it going to look like that, like that, like that, like that? Well, it should go through that point, but how are we going to draw it? So let's substitute a point in and say, how do we know when x is 1, how are we going to work out what the y value is? If we're given the input, just substitute it in to get the output. Now I'm going to substitute it into this version of the equation to go y equals 0 times our x value, 0 times 1 plus 4. Okay, so 0 times 1 is 0, plus 4 gives you 4. So wait a second. Y equals 4. But that's what we had before. That's what our equation is. Y is always equal to 4. So if we have the number 1, our output's 4. What about the number 2? What's the y value? What's y equal to? Well, we don't have to even substitute because y equals 4. What about this value here? When x equals 10, what does y equal? Y equals 4. Could sound like a stuck record here. So what about here? X equals minus 5. What does y equal? Y equals 4. Y always equals 4. So no matter where you are, it's always 4. So our straight line looks perfectly horizontal, going across like that. There it is. Now let's interpret. Our gradient we said was 0. Why does it make sense to say that our gradient is 0? Well, gradient is how steep the line is. Well, does this have any steepness? Is it going up? No. Is it going down? No. So it's gradient 0. what about another way of looking at gradient? Gradient is for every one step you go across, how far up do you go? Well, for every one step you go across here, you go across, you don't go up or down at all. So gradient's 0, because for every one you go across, you don't go up or down. You just go across. You don't go up or down. Okay, so what about gradient is rise over run? Let's look at it that way. So I'm going to write this last one down and go, gradient is rise over run. Okay, so let's choose any points. And we're going to go from this point to this point. So we're going to run from -5 to 10. Cool, so we're going to run 15. And we're going to rise from 4 to 4. So we're not rising. No matter what, we're not rising. So we didn't even need this 15 part. We're never rising. So our gradient must be 0. Always 0. Hello. Okay, so there we go. That's our gradient. That's what the graph looks like. So now we can do some quick sketching. And I'll ask you, y equals -5. Sketch it in 2 seconds. Tell me what the gradient is and what the y-intercept is. So pause the video. Go. So Cartesian plane. X, y. There it is. There it is. Y equals -5. Y-intercept is -5 because y is always -5. What's the gradient? Gradient is nothing. 0. It's not going up or down. So it's 0. Let's put a nice arrow in. Y-intercept 0 -5. We'll put it there. Y equals -5. Label our graph. Done. Okay. Let's do a final one and say, what about some more quick sketching? Y equals -7. Go. Okay. Let's see. Who's going to win? I'm going to win. I can just tell it. I've got my winning ways, or have you finished drawing it already? Y equals -7, but I have to change the color. There. Oh, you haven't labeled your y-intercept, have you? 0 -7. I'm even going to say you didn't label your function. Done. Oh, anyway, but we get the point. Gradients, gradient equals 0. Y-intercept is 0 -7. That's what our straight lines. So horizontal lines are just y equals something. And then the second part that we've looked at is to say, what about a graph that looks like, let's go this bright blue and say x equals 4. What does our graph look like? Let's look at it in the same way we looked at our first graph. Now, we're not going to try and put this in standard form because it's impossible. There's no standard form for this. It's not a function, so we can't write y equals something. But what about this point here? When x is 4, y is 0. What is x always equal to? This is our stuck record thing, 4. So what about this point? When y is 1, what's x? X equals 4. What about here? I'm going to go up a little bit. Y equals 2. What does x equal? X equals 4. Okay, here, let's go down here. I'm going to go all the way down here and say, okay, when y equals -10, what does x equals? X equals 4. X always equals 4. So if you're sitting at 4, then it's always going to equal 4. There it is there. What are the chances that I can get this right? So I'm going to cheat a little bit and say, there we go. You see, it's exactly where I had my points there. So x always equals 4. So that's what our graph looks like. And the last bit that we're going to look at is, what's our gradient? So for this function, our gradient is what? 3 ways of looking at gradient. Let's start with our m equals rise over run, because this is the one that we use to determine it. So gradient rise over run, cool. So let's choose 2 points. I'm going to choose that point and that point, as long as they're different points. So let's start with our run. We're running from 4 to 4. So how far are we running? How far across are we going? Or are we not? Then we're done. Can we ever divide by 0? So in this case, this was 2 over 0. No. So our gradient is clearly undefined. Okay. Let's look at it in terms of gradient. We could also talk about in terms of gradient is for every 1 step across, how far up do you rise. Okay, so in this case, for every one step you go across, well, that's blown out the water. We can't even talk about going across. For every one step across, but we never go across. So it's undefined because we can't even talk about for every one step going across. For every one step we go across, but we don't. Okay, and the last thing of gradient is slope or steepness. How steep is this graph? Well, that's not steep at all, right? The graphs we did before. That's steep. That's even steeper. That's even steeper. But that, it's undefined. So that would be our final way. So there we go. Goodbye.